I just wanted to take a minute and go over this question on an example or a problem where you take a limit of a function at a point and you end up with the numerator equaling some number and the denominator is going to 0. So we have to determine if it's plus infinity or minus infinity, and there's a couple different ways to go about it. So I'm going to open up the textbook here, and this is just a printout of the textbook. If you open it up in the CDF player, you can actually interact with it with the interactive features in it, but here I just write on top of it. So there's a couple ways to look at it, and the student that answered the question talked about this table. You could plug in values. In this example, the limit as x goes to 0 of 1 over x squared, if I plug in values to the left of 0, right, this is going to 0, but it's always negative, right, this side is negative, but negative squared is going to end up being positive. So I have something that's going to a positive number divided by going to 0, but that going to 0 is positive. So overall, I'm positive infinity. If I'm looking at it to the right, I'm positive, right? And so I have the numerator is a positive number divided by the denominator, which is going to 0, but it's always positive. So I end up with this positive infinity. There's a couple of examples in your book where it might not always be the case that the limit on the right is going to equal the limit on the left. Graphically, right, it makes sense. I can see this. On the right side of A, I have positive infinity. Here on the right side of A, I have minus infinity. Graphically, it's pretty straightforward, but when you have a function, it might not always be realistic to graph it. And it might not always be realistic to plug in points. So if you can just think of what's going on at the interesting points when you have a vertical asymptote, it's going to be when the denominator is 0. In this example, they actually go and graph it. And here's the graph. But if we didn't have the graph, we should be able to still evaluate this algebraically. And we could plug in points. You could always plug in points on the left side of 3. And if you do that, you're getting larger and larger negative points. But if you also go about the limit as x goes to 3 from the left of what's going on here, x minus 1 quantity squared. If you focus on what each one's doing, right, so I have the limit as x goes to 3 on the left. So what's going on here? 3 minus 2, right? It's a positive number. I don't really care what number it is. I know it's a positive number. So if I'm taking a number that's less than 3, but really close to 3, and I subtract 2, I still get a positive number. Here, it doesn't really matter what's under or what's in the parentheses here, because this squared, it's always going to be positive. So this term's a positive number, right? We know it's, in this case, it's not going to 0. This is the term that's going to 0. That's in the denominator. And if I'm on the left side of 3, right, then I'm like at 2.9. 2.9 minus 3, this is a negative number, right? And this one's going to 0. So that's going to make my whole denominator go to 0, while my numerator is just some positive number. And my whole denominator is going to 0, but overall it's negative, right? Negative, but going to 0. It's never 0 because you can't plug in 0 in the denominator. It's because we never actually hit 3. We're always just slightly to the left of 3. So in this case, it's going to be minus infinity. And you can see that from the graph. Right? You could plug in 2.9, and then you could plug in 2.99, and then you could plug in 2.999, and you could just verify that the numbers are getting larger and larger negative. But if you kind of think about it this way, you don't have to worry about what the numbers are. Is it positive, negative, or is it in which term's going to 0 there? And this is an example of it kind of analytically with this 5 plus x over x. So if I look at the limit as x goes to 0 from the right of 5 plus x over x, right? My number, if I draw a number line here and I have 0, I'm on the right side of 0. So I'm always larger than 0. So this is where they're doing that 0.01, 0.001, 0.0001. And they're plugging in their computer and getting a number. If we do it, right, basically the top's going to 5 and the bottom's going to 0, but it's always positive. So I have positive divided by something that's positive going to 0, that's positive infinity. But if I look at the limit, hit a wrong button there. If I look at the limit as x goes to 0 from the left of 5 plus x over x, right? I still have going to 5, right? So it's positive up there, and it's going to 5. And then here, if I look at that number line, I'm on the left side of 0. So this is going to 0, but it's always negative. So always negative, but going to 0. So that's going to go to minus infinity. And if I was to graph that, you could verify that's what's going on. And this is what they're saying here. If you read this in your book, you can see while that's going on. So there's some more examples. You got to be a little bit careful. If your numerator goes to minus a number, you have to take that into account. So this one is an example where that numerator goes to minus a number, and then that's kind of switching the role of minus infinity and infinity. Those are examples of trigonometric functions. And it looks like my computer froze, so I'm going to stop the video. If you have any other questions, please let me know.